Good morning, everyone. Thank you for joining us for this webinar, where we will be discussing the solar lighting system with emphasis on batteries and battery sizing. My name is Nadia Smith. I'm BEKA Schréder's Senior Communications Officer. Please note that we will be recording this webinar and we will upload it to our YouTube channel. For any specific questions, the Q&A session will be held after the presentation. So let me introduce our speakers to you. Grant Combrink is our Marketing and Segment Development Manager. Gert Labuskachny is our Solar Design Engineer. And Gordon Ahrens is our Solar Segment Manager. Today's agenda looks as follows. Grant will take you through the solar lighting introduction. Gert will discuss battery technology. All the speakers will then take you through the battery calculations, and Grant will finish off by sharing the marketing material that's available with you. So, without further ado, over to you, Grant.
Yeah, thanks, Nadia, and warm welcome to everybody. Let's just do a little reminder of who we are. It's always good to go back to our roots so we know where we come from, so we pave our way to the future. So yes, we are market leaders in the outdoor lighting space. 40 plus years of lighting excellence in the market, and over 10 years supplying LEDs into the market, and we're very proud of our local manufacture. You know, we leading the manufacturing with regards to LED luminaires and glass fiber poles. That's really the emphasis of our business. Just to go back to our origins, in 1978, starting off in Namibia, a neighboring country, moving to South Africa in 81. Then in 2002, we entered into a partnership with our Belgian company called Schréder, the multinational lighting company. And then in 2013, we became solely owned by Schréder, and now you know us as BEKA Schréder. Again, very proud of our local employment and our factory, where we have, as you can see there, the staff complement and obviously our BE rating, which we are very proud of. Okay, something that we really are proud of, and it's been a longevity within our business, is our quality. And the quality, we were one of the first companies to be awarded with the ISO 9001. And the continued quality with that, we now also ISO 14001 certified. So you really will see that within all our luminaires and our offering to the market. Again, the commitment to energy saving, which is on everybody's lips at the moment, even more than usual. So we do try and push our savings up to 85%, where we do offer you a controls component with our, and please go look at the website for our Terra and etc. platforms, where we really, it's not just about saving on the unit itself, but really look at the added value that we can give to you. Again, we are very proud of our in-house R&D department that comes up with these amazing products, designs, custom designs, and all our specific control systems and technology. So today, we're going to focus on the road segment. We do cover, as you know, all the segments within the lighting industry, but today we're going to look at our road segment and focus on solar. Something that part of the whole group is we are experts in lightability, and lightability to us is bringing meaningful moments to people by enhancing safety, well-being, and sustainability in public places. With regards to solar, something that we really want to drive home is obviously the sustainability, renewable light for public spaces. We drive a high specification and illumination, you know, and that's very important because we want to get the light where it is needed most. And we really want to drive that into all the applications that you have and that there are. So today, just looking at the solar lighting system itself, we really want to bring this down so you can really focus on what the technology is offering, what is out there in the market, and how to look at a solar system. It's not just about harvesting the sun. It's really understanding what the storage is, the lighting components, because at the end of the day, you still have a light component. There's a whole bunch of electrical components attached to that, which we're going to focus on. The mechanical component, it is still a light. We still want to get the light into a specific area, and obviously going forward also look at connectivity. So that's really the whole solar system that we want to look at today, and we're going to be focusing on the storage units and batteries. Okay, so let's get into some of the detail. So some of the essential terms that you need to know: specific battery autonomy. So this is known as the discharge time. Battery autonomy is a measure of the time for which the battery will support the critical load. Now, please remember that we want to support the load. The battery autonomy is very important with regards to this, and you'll see this repeated throughout the presentation. We need to support the load, and the battery will do that for us. Remember, autonomy is a function of the battery charge state and the capacity and the load size. Okay. The depth of discharge, now that's it, logically speaking, as it says, it's the amount of energy that can be used in a battery when it is processed from fully charged state to fully discharged state. Therefore, the depth of discharge, or DOD, is a very important factor in calculating the size of the battery in solar streetlights. For instance, the lithium batteries, the depth of discharge will be 80%. So you do not want to push into that 20% ratio of the depth of discharge, and normal lead gel batteries will be only 50%. So please keep that in mind when we're doing this. Gert, I'm going to hand over to you just to get into some of the battery details.
Yeah, thanks, Grant. We want to start off with just giving you some advantages and disadvantages of the different technologies. So let's all start off with our dependable lead AGM batteries. So advantages of lead AGM is they've been around for over 30 years. So the technology is very stable. It's very safe in terms of any fire risks. Also, it's the cheapest technology when it comes to purchasing the complete system. But unfortunately, lead does have disadvantages. It's much heavier, so it's much more difficult to install, especially when it comes to poles and the heights that you work on. Operational temperatures are limited usually to 50 degrees Celsius, but if you get a very good lead battery, you can go up to 60 degrees Celsius. Then, of course, when it comes to lead, there's always the replacement that you need to do. You're looking at between 3 and 5 years. Normally about 1,000 cycles. If you, like I said, got a very good lead battery, you can go up to 2,000 cycles, but this always depends on the environmental conditions. In this case, environmental conditions is very critical when it comes to designing and the use of your battery. And it, of course, the lead is limited to a maximum charging current of only 20 amps. Again, lead does only offer a 1-year warranty on the technology. So let's move over to lithium, which is the more prominently used technology currently in the market. Advantages of lithium, it's got a higher power to mass ratio than you get with a lead AGM. This relates back into that the pack will be lighter, so the mass is less, easier to install, and it's much easier to integrate into sometimes even the luminaire itself due to the shape flexibility that you have with the lithium cells themselves. Then you get the advantage of the 80% depth of discharge of the lithium pack. So meaning you have more energy that you can use from the specific size that you've got. You get up to between 5 and 7 years of life, which relates to between 2,000 and 3,000 cycles. And of course, this increases significantly with the reduction of depth of discharge. So if you were to say only discharge your lithium battery only to 50%, you can achieve up to a 10-year life on this sort of technology. It's got a higher charge current than with your lead option of up to 50 amps. So that is the maximum rate that you can charge it from either solar or mains power, of course. Unfortunately, this does have disadvantages. It's got a higher initial cost than your lead type batteries. You're still limited to the 50 degrees Celsius operational temperatures, unfortunately. And you need special charging algorithms for lithium batteries, and you cannot just exchange it in the same system where you used to have a lead AGM. There is some adjustments that you need to make to the charging side, and it is limited to a 3-year warranty, which is better than your lead, but also you only get 3 years of warranty on that. Then the more newer technologies that we offer is what's called the supercapacitor modules. Now, the advantages of these modules is you get a high temperature rating of up to 75 degrees Celsius, which is nice for your higher temperature areas like the Northern Cape, Namibia, Botswana, those sort of places. It's got a high charge rate of 50 amps. It's similar in mass to lithium, which makes it easy for installations, especially at high heights. You do get a 10-year operational warranty and a 45 years expected life on these systems. But of course, it's always dependable on conditions, etc. But this is what sort of the figures we're looking at. Some disadvantages, it's got a very high initial cost, but one must remember because of the life expectancy on these modules as well as the operational warranty, it does have a better ROI for the complete system. Unfortunately, it does have a longer lead time than lithium batteries as well. So here's just a quick summary of the different sort of technologies here. If you look at, for example, the voltage range, you see your lead AGM full charge voltage is at 13.5. The lithium is at around about 14.2 to 14.6 volts. So there is typically where you'll see your algorithm needs to change, and where you cannot just replace a lead system with a lithium, because if you look there at that charging voltages, it will mean that if you put a lithium battery in a lead application, your lithium battery will not be fully charged by that charger. It will always be running at about the 80 to 85% fully charged state. Of course, that again will result in lower life expectancy on the lithium. So then you will be surprised that your lithium only lasts as long as your lead, but you didn't expect it when you bought it. But it's because you haven't been charging your lithium battery back correctly. Supercapacitor ratings is very similar to AGM, but the one thing you'll notice there is that the lower side of your charge voltage cutoff is 8.5. So it has a very nice deep discharge capacity. In terms of capacity, lead 1280 watt hours, of course, and you can run through that. Then, but when you look at the depth of discharge and you take that into a consideration, if for lead, out of that 1280, you only have 600 watt hours of usable capacity on that battery itself. So that meaning you need a bigger battery to get the same sort of power that you would need for a lithium, which if you look at those ones, you get for the bigger 1280, you actually have 1049.6 watt hours available to you when you use that sort of technology. And the benefit of the supercapacitor is you actually have 100% depth of discharge. So you can use the complete 1000 watt hours out of that module without degrading the life of the module, because a supercapacitor is not a chemically driven storage device. It actually uses a different sort of method to store its energy. And then, as we note, I'm just looking quickly what some nice interesting points. Yeah, the temperatures, as we mentioned, which is nice. If you look at the charging temperature, for example, lead 0 to 50, lithium 0 to 45, right? And then on the supercapacitor, you have -10 up to 75 degrees Celsius. And what this means is your supercapacitor, you can actually charge the battery below 0 degrees Celsius. So if you have an environment where it's in winter, it's below 0, you do not need to heat the battery environment to actually charge it. It can charge at sub-zero conditions. And then, of course, like we mentioned, the projected life on lead up to 2000, lithium you can get up to 3000, and with a supercapacitor you're looking at about 20,000 cycles. And if you convert that over 2 years, you can see that the supercapacitor, you are running over 30 years on that sort of technology. Just some dimensions to give you an idea of the size of these things. The lead is very similar in size to the same capacity of lithium battery. Were you to use a, let's call it the old drop-in 100 amp size of battery, and on the supercapacitor it's slightly actually smaller than what you do have on the lithium. Weight, again, very important when it comes to putting up things on masts and poles. You need as little as possible so that you do not have so you do not need such big poles, and reduce, which gives you a reduction of cost, of course, where you can see the lithium and the supercapacitors have a very nice benefit when it comes to mass. Gordon's been just so kind as to add the to give you a price indication of what it is at the moment. What was quite interesting for me when he shared this with us is that when we previously had a look at this presentation, the lithium pricing, as you can see there, is about the same, is comparable to lead, is about 3.84 times more than lead, but we have seen a major increase in pricing on lithium due to the global conditions that we are living in these days. But what is actually quite nice is if you compare the lithium versus the supercapacitor, there you'll see it is slightly higher, but it is very nice to see that the two are coming much closer to each other there. So yeah, thanks Grant for the opportunity to share this technology, and I think we go back to you.
Thank you. Thanks, Kat. Okay, let's so you're more than welcome to get your calculators out. I just want to make sure everyone's muted there.
Is this Kat,
I think we just need to mute.
Speaking to Farad from BEKA in Durban.
Hold on, there's
Good, sir. Good. I think it's the first time I'm chatting to you, but I did receive your email and responded to you. So, can I just find out, did you receive the email?
Okay, sorry about that. Okay, let's shoot into the solar battery calculation. Please get your calculators if you wish to run through. So we're going to go this step by step. Just a little bit of a reminder of basic maths and some science back in the day at primary school and high school. But let's just run through this systematically, because we will give you an easy way to calculate this and to check certain specification to make sure that you're getting what you're paying for and what you need. Okay. So obviously, let's just go into the data that is required to do the calculation. First, the rated LED power. Then we'll need to look at the working voltage from the LED. Apologies, from the battery. The LED output during night at 100% or specific dimming profile, the days of autonomy, and the depth of discharge. Okay, so this is as we went through previously. That's why it's important to know the terms. Okay, so now let's assume that we've got a 30 watt solar street light output power with a 12 volt battery. Then let's assume it has a dimming profile. We say that it'll work for the first hour at 60% output, 5 hours at 100% output, and 3 hours at 80% output for the duration of the night. So then we assume that you're looking at about 8 hours at 100% if we had to consolidate all that. Okay. This unit specifically will have 3 days autonomy. In other words, it will support 3 rainy days or cloudy days. This is a lithium battery, so therefore the depth of discharge is 80%. Okay. So now let's do the calculation. Okay, you're welcome to calculate with me. So first of all, let's look at Ohm's law. We all know it's power is equal to voltage times current. So first of all, we look at the amount of current running through the system. So 30 watts divided by 12 volts will give us 3.5 amps. Okay. Then we have to bring in the amount of time that it is running. So we look at the 8 hours at 100%. Then we take the 2.5 amps and we times it by 8 hours to give us a 20 amp hour calculation. So far, this is what the size of battery you would need. But now we need to bring in the days of autonomy. And that would be then for the 3 days. And that will now give us 60 amp hours. So now you can see the size of the battery is growing. Then we also have to consider the depth of discharge. So we have to take that into account because we don't want to use that 20%. So then this will increase the size of the battery to 75 amp hours. Okay. All right. So that's just a basic idea. So we're going to go through a few examples now. So you'll be able to get in the flow, and you're welcome to calculate in the background. So Gordon, if you don't mind just shooting up again to the previous slide, then we can just show the certain, just go one slide up. Okay, just as a reminder, rated LED power, the voltage from the battery, the specific dimming profile in hours, days of autonomy, and the depth of discharge. Okay, all right, let's just shoot through again, Gordon, thank you. Okay, so now what is wrong with this data? Okay, so we've got a 100 watt unit, 25.6 volts, a 40 amp hour unit. Now it says 10,000 lumen system output. Okay, now please always be aware of the lumen output that is quoted on any specific specification. We've got a 12-hour operation here with 3 days autonomy. Okay, and as you can see there, it's a lithium battery. Okay, so first of all, let's calculate the current in the system. Typical Ohm's law again, 100 divided by 25.6 gives us 3.9 amps. According to this data, it's running for 12 hours at 100%. So if we look at the daily output of this, it is the 3.91 amps times by 12. It's really giving us a 46.8 amp hour. So really, just based on the current in the system and the amount of time and duration that needs to operate, we're already above what is specified in the data. Okay. If we now bring in the claimed days of autonomy, we have to times that by 3. You can already see now it's over 140 amp hours that is needed to run this output. Then it's we have to bring the depth of discharge into account. We're sitting at over 175 amp hours. Okay, so we really need to start looking at this data to go, and that's a quick calculation that you can do on the side to say, okay, for this lumen output and for this load, for this output, for that duration, this battery actually needs to be 4.5 times the size. What is going on here? You can go back to your supplier and say, what is this? And they can say, we've got a more specific dimming profile. Apologies. So if we had to calculate it through, the dimming profile will actually only give you 4 hours at 100% output. Okay, so let's calculate that again. So we go back to the current and we say, okay, 3.9 amps times 4 hours. Okay, so it gives us 15.6. Okay, that's more in line. Now, as soon as we bring the days of autonomy, we're already over the battery size. Bring in the depth of discharge. So the battery is actually still too small. So this is a quick calculation that you can do. So if you look at it, a 40 amp hour will not support the load of 100 watts for that nighttime duration and the autonomy. And it's not going to give you that 10,000 lumen that you require. Okay, so that's just a general overview again. I'm going to hand over to Gordon to go into a specific calculation, and this battery size calculator we will give to you. So Gordon, you want to shoot through there?
Thank you, Grant. Good morning, colleagues. Good morning, everyone. I think it's most important to understand we're going to look generally in two segments. We're going to be looking at a battery calculator, as is the data that's been supplied. And then we're going to look at a possible dimming profile to be able to meet the same battery size. So as Grant rightfully said, that will be supplied to you directly after, and please have a chat to your local salesperson. They would be getting extensive training, and they most certainly would be able to assist you in that regard. So as you can see there, I think Grant has worked it out, so we shouldn't spend too much time here. But there's your 100 watt as far as your luminaire is concerned. The battery voltage of 24, so you would always use a figure of 25.6. You have 12 hours operation on there. We have 3 days autonomy, and voila, you have 175.78, as Grant previously alluded to. So what do we do to try and make this work? So we say, okay, let us try and calculate a dimming profile that would suit at the end of the day. So what we came to is, if you use a 22% dimming profile, you're able to make sure that that battery can operate within the 40 amp hours specified. However, one needs to consider the following, that at 11 of the hours, you're operating at 20%. That gives you 20 watts of power. You as a customer are paying for 100 watts. You're getting 20 watts of power for 11 hours of the 12 hours that have been specified. The further hour is at 40 watts, and that is right in the beginning of the evening. Normally, you would have such a luminaire mounted at a pretty high mounting height of plus minus 10 meters. So you need to ask yourself, what type of light output, once this dims down to 20%, are we actually reaching on the ground? Grant?
Okay, let's do another example. So I think you're getting into the flow now and understanding how the calculation works. So let's do another test. So here, they're specifying that we've got a 42 amp hour unit. It's 120 watts, and look at this lumen output. It's big, so you can think naturally, can replace anything up to a 250 watt HID unit street light. This is a fantastic specification. So let's calculate and see what this is telling us. Again, Ohm's law, we calculate the current, and we're sitting at 4.7 amps. Okay. Then we go to the next slide, and the next line. And according to this, we've got 12 hours at 100%. This is claimed or assumed because it's a little bit, we're not sure based on the specification what they're saying here. So let's say it's 12 hours. So already we can see we're sitting at over 56 amp hours. Okay, we have to take the days of autonomy. As I mentioned there, the backup, we're sitting at 169 amp hours. Sure, so this battery is getting massive. If we look at the depth of discharge, we're sitting at 211 amp hours. Okay, so now we need to look at this and say what's going on. Again, this battery, according to be able to support the load, should be 5 times the size. Okay, so something is not right here. Again, let's investigate, and we find out again that we're looking at 4 hours at 100% bright. This is assumed or claimed, whatever the supplier will tell you. So we calculate back again, and we get a battery size with 4 hours at 100% of just under 19 amp hours. We bring in the days of autonomy. We're sitting at over 56. We bring in the depth of discharge. We're just over 70. So now, logically thinking, we have a 42 amp hour battery that will last 2.3 hours at 100% max if we had to calculate back again to try and get it into some sort of form of understanding. Then, obviously, with the depth of discharge of 80%, you are again only running at 20%. So this will equate to only just under 3,000 lumens for 12 hours. Again, what are you paying for? What light is coming out of you? What is the mounting height here? It is very important to understand what the storage unit is going to do and to support what load. Okay.
Good. Thank you, Grant. Yes, I think as Grant has rightfully said, I think we've really rushed through all the calculations there, and it makes 100% sense, as Grant has mentioned. So I'm not going to spend too much time here. One thing I do want to spend a bit of time on is most certainly the hours which are mentioned at 100%. As you can see right at the bottom in the orange block, you have 2.3 hours. 2.3 hours, once you translate that into a dimming profile, as specified by the customer, not ourselves. The customer, as you can see on the left-hand side, in the working time has specified 12 hours of operation. Those 2.3 hours at 100% actually translate to a 19% overall dimming profile. So what does that bring us? 19% for the first hour brings us 12 watts at 10%, and then a further 11 hours at 24 watts. And again, if you remember the previous luminaire was 100 watt, 120 watt, you may even have a 12 meter mounting height. You need to ask yourself on 24 watts, what is actually going to reach the ground. So then we have calculated it into, obviously, that is the 19% dimming profile has been calculated to make sure that the battery fits its size of in the 19% and up to 40.08 amp hours. Good. And then we go further at just another calculation. Here we have a 72 amp hour battery. We haven't circled it, but you have an 80 watt luminaire, 3 rainy days. And most importantly, in this case, at the bottom, the customer has actually specified, unlike the previous 2 examples where we assumed 100% dimming profile, since it wasn't specified, here the customer has actually specified a dimming profile. So they've said to you that in your first hour, you would have 50%, then 70% for the next 2 hours. The following 5 hours will be at 100%, the following 2 hours at 70%, and then the last 2 hours also at 40 watts. So which sounds quite good, I suppose. And then this is his schematic of his dimming profile, and most importantly, once again, it seems impressive. He's specified right at the bottom in the middle. He specified 9.3 hours at 100%. Nice and impressive. Let's do that. So we took his dimming profile, which is 12 hours. We divided it into, as you can see on the top right-hand side, the 12 hours. The 9.3 is represented there, but the 9.3 that you can see is only a 77% dimming profile, which, by the way, is quite a good dimming profile. However, where lies our problem? Our problem lies with the battery size. So remember, previously, the battery size was specified at 72 amp hours. Therefore, we need a battery of 216.56 amps to actually sustain the supplied dimming profile. Good. Then moving on to the next example, and perhaps this is where one should, again, as Grant has said, just understand the Ohm's law, apply it, and it's very easy. And so here they have not specified a battery size. However, they've specified to us that it's 844.8 watt hours, and it's a 12-volt system, which they've obviously had 12.8. If you go and do that calculation, it actually comes down to show you that what looks impressive here, and again, it's a 100-watt luminaire that we're looking at, and it comes down to a 66 amp hour battery size. On the bottom left, again, they have supplied us with a dimming profile of 1 hour at 45%, 4 hours at 100, 3 hours at 50, and 4 hours at 25. I think most important here is that they've also stated that it comes with PIR motion sensor. Now, that is quite a challenge because it makes calculation, call it almost impossible. However, one would appreciate that somewhere in the process, you actually need to have some spare capacity in the battery to be able to ensure that your PIR motion sensor, together with the dimming profile, is actually going to work. So what do? On the top is his dimming profile at 6.95 hours at 100%. It translates to a 58% dimming profile. And what do we need? So remember, it was 66 amp hour battery. We need a 203.91 amp hour battery. Then going through to the final calculation that we have for you today, they are specifying a 33 amp hour battery. And interesting here, they have not said 1, 2, 3, or 4 days, but they've actually specified the hours. And we all know that 36 hours is only 1.5 days of autonomy, which is quite interesting. We then did the calculation based on everything that is provided. We most certainly have included the 1.5 days as autonomy days. And, you know, what do we need? We need an 87.89 amp hour battery. So again, there, you know, you can ask yourself the questions. That was a 33 amp hour battery that was specified earlier in the page. And that's me done, and thank you very much for your time and signing in with us. Thank you.
Okay, so that's all good and well, and but let's just consider a few things. What is important here is understanding the technology versus the price. So what are you paying for? That is the most important here. What is the number of cycles of the storage unit? What is the longevity of this? What are the climatic conditions, the application, the environment? What is the location? Is it accessible? Site maintenance, what is needed with regards to the site? So we've got to ascertain where this is going. We need to understand the days of autonomy, again, the climatic conditions, and the geographical location is very important. Does it have a sensor or not? By no means this is saying that a sensor doesn't work, because it has its application. And what type of sensor is it? Therefore, when is it going to be dimmed? How is it going to be dimmed? Remember, a lot of PIR sensors, you don't want to mount this too high. You need to understand how this is going to be mounted first from a height perspective. And will the PIR sensor actually pick up this movement? A lot of these units only can be specified from a sensing capability to a certain height. So please take that into account. The dimming profile is very important, because you want to know how much you're going to get out of this unit. You need to understand what am I paying for and what is the output I'm getting out? What is the wattage I'm getting out? What is the light output I'm getting out? If I'm only working on 20%, this is not what I'm paying for. But then there's also another specific requirement here that you'll need is, do you want some light or do you want a specific light level requirement? So when looking at all these specifications, you might just want some light. So that 20% dimming profile will be okay. If it's 3,000, 4,000 lumen for that period of time, just obviously be careful how high you're mounting it. But then if you want a specific lighting level requirement and you moving from a designed specific road requirement, you can't just look at any PIR sensing unit with a lowering light level. It's not going to be to the specification required. So the biggest thing here is the size of the storage unit. Can it support the load? That's the most important that you want. You need to know what sort of wattage you're paying for, what sort of lumen out you're paying for, and the quick calculation on a battery size will tell you that, and you can question your supplier. So please contact us for all these considerations. So when you're looking at solar, it's not about a quick, yes, it's plug and play to a certain extent, but understand all those considerations, because this is what you need to take into account to actually get a unit that is working correctly. Okay, so just some of the projects that we really proud of. As you can see here in front of you, just a quick snapshot of some of the applications and installations that we have done. If we look at our portfolio, we do have an extensive portfolio in the solar range. We've got our 4th generation BEKA solar unit now. We've got a solar pole, which is more of an aesthetic look and feel, where we've got integrated components, wraparound solar panel. We've got our solar flood, real high mast application and flood lighting application. So we really have got an extensive solar range that we can offer you. Multiple applications, as you can see here. We're really trying to make these applications suit, or our products to suit all of your applications. So with the BEKA Solar, we will, obviously this is available to download on our website, and we will have it available. As you can see here, we give you all the extensive information you need with regards to what battery size you need for what geographical location, with the specific days of autonomy, so you can really choose what size of battery you need, and obviously the dimming profile, the wattage of the luminaire, that it's all that you need for the certain output. We've also got our solar pole, where we do exactly the same thing with regards to dimming profile, battery size, days of autonomy, and the location where it can be mounted. In our solar flood, you can see we do everything from a single unit all the way up to a high mast of up to 20 meters, where we can supply you with 6 units on a mast. And then let me hand over to Nadia.
Hi again. Okay, so it's time for our Q&A session. You're very welcome to type your question, but just please keep them short and to the point in the chat. But otherwise, you may also use the raise hand function, and we'll unmute you so that you can ask your question.
No, please, any question, if you want us to go back in the slides and run through a calculation again, please. I see there's a hand up there.
Hi, Philip. I'm going to unmute you quick. So I think you...
Thanks for a very interesting presentation. I have several questions. Do you expect the supercapacitor module to take over the lithium market and thus lower the cost on economy of scale?
Gert, do you want to answer that one?
Yeah, Philip, we are seeing a much bigger uptake on the supercapacitors. Just to give you an idea, the supplier we are working with is doing some major projects in terms of areas like Namibia and Botswana as well, where people there have actually started rejecting the lithium technology because for those sort of applications, they actually need to put air conditioners in the sort of environments where they are charging these batteries. So yeah, even in our country, we do see in the northern provinces, and especially in places where maintenance is an issue, you know, mines that are quite extensively out of suburban areas where you have cherry pickers and those sort of things to do maintenance. It's a very popular technology for that. So yeah, we do see it picking up, especially with the lithium prices the way they are going now. It does seem like we are going to get to a faster price parity than was originally thought of, and I do also see the supercapacitors becoming a bigger player in terms of your residential and commercial applications. So I hope that answers it.
Thank you. My second question, metal halide batteries offer far better temperature tolerance. Do you consider that a practical alternative?
I have also looked into nickel metal halide technologies, but what was quite interesting for us when we explored that sort of thing is that the pricing on that technology is actually quite high, being that most of the better performing cells to make up these sort of batteries do still come out of Europe. The offering from the Asian market is not acceptable for us in terms of performance. So in terms of pricing, it is actually quite high compared to your lithium, taking lithium as a base sort of pricing.
Okay, thank you. My next question is, how successful has your application been in rural towns from a security point of view?
Yes, Philip, thank you. It's Gordon here. Most certainly, obviously, security is always a concern, but what we have done, and if you go to our website and you go under projects, so there are, you know, anti-theft mechanisms which we've employed for argument's sake on the solar pole, on the solar high masts. We don't believe that we're going to have challenges there. It's quite a massive structure to cut down. But most certainly, I think theft is uppermost in all our considerations in the design phase. And so I must say that what we are finding more and more is that communities are starting to realize the value of their areas being lit. And most certainly in cases, I know of municipalities that are actually planting those lighting poles within the yard of the people who live in the rural areas, which means they're essentially asking them to take responsibility for the safekeeping of that particular mast. So I think it's most important for us as professionals not to arrive and dump technology onto a community, but that we rather engage meaningfully with the community to ensure that they are on board. And I believe that your project has a bigger chance of success.
Just to maybe add on there to Gordon, Philip, what we're also seeing, the new solar pole option, where we have wraparound panels and things. It seems like that has been a better theft deterrent than your old traditional stuff, but of course it is application dependent.
Thank you. My final question, do you foresee an integrated solar panel in the luminaire to reduce windage and to be less enticing for theft?
I can take yeah, Gert, go for it.
Yeah, Philip, we are looking and working with these sort of technology and options. So it is something that's going to come out soon. Of course, one must remember luminaires like that do have their limitations, and one must be very careful in terms of your environmental conditions for that sort of luminaire, as everything is boxed together. There's no airflow or cooling. Is a bit of a struggle there. Gordon, you want to add something maybe?
Yeah, Philip, if you don't mind, just to perhaps pop Nadia an email, or in fact, we probably do have your email address. If you wish, I'm quite happy. We have done a presentation, the difference between a lot of people refer to as all-in-one. So there is solar terminology that one needs to understand between an integrated and an all-in-one. One must bear in mind that in an integrated system, it almost becomes like an oven, simply because it's all in one and you've got the heat beating down. Where if you look at, for argument's sake, our BEKA Solar, you will always be pointing the solar panel to the north. You also have the amazing advantage that the items below it are all in shade most of the day, so that ensures that you don't have high temperatures in the sun. And the other plus point of all of that, and if you think of a road lighting installation, if you talk about an integrated solution, it always has to face the road, which means that if that panel is at 5 degrees, going around the corner, for argument's sake, that panel will suddenly be getting sun at -5 degrees if it's on the wrong side of the sun. Where on a BEKA Solar, you're always able to aim the luminaire perpendicular to the road surface, and you will be able to shift your panel, which is always facing north, in a different direction, and therefore you will optimally harvest the rays of the sun.
Yes, I'm definitely interested in that presentation. Thank you very much.
Sure, we'll make a note and send it to you. Thank you. And
Okay.
by the way, that is for anybody, Nadia, who wishes to have that presentation. Please just drop Nadia a message and we will ensure to get it to you as well, yes?
Okay, great. Thank you. Okay, Ian was next. Hi, Ian.
Hi, can you hear me?
Yes, we can.
Okay, I've got a question which is a slight twist on the presentation. I have got a couple places where customers need lights installed that during load shedding the lights stay on. Do you have an option of, instead of having a solar panel, because where these lights, a couple of these lights will be installed is on the south side of a tall block of flats, so the chance of them seeing sun is rapidly approaching zero. Do you have a solution where you could have a charge circuit or something like that, that when load shedding comes along, it can run off the battery, and as soon as mains is restored, it can then charge up again?
Nadia, I'm happy to take that. Yes, Ian, thank you. We most certainly have a solution. We have a fantastic R&D team, which includes Gert, which has really worked hard on that. Depending on what wattage is involved, you know, there's quite a few options. My suggestion is to perhaps, you know, we can get a salesperson to contact you and discuss the particulars with you. But most certainly, we have, if you wish, a hybrid type UPS backup system where we are able to run through extensive load shedding for a period of up to 6 hours if it's, say, a 53-watt luminaire. So most certainly that does exist. Absolutely.
Okay, cool. I'll give Rian a shout and ask him if he can meet me on site, and we can then take it from there.
Is that Rian Bub, right?
Yeah.
I'll have a chat to Rian, but he's also aware of that because we're doing actually the solution for his colleague in Cape Town.
Okay, cool. Thank you very much.
Okay, thank you. So then we've got some questions in the chat. Tiborgo is asking, when doing the calculations, do we assume an 8-hour day or 12-hour day for night illumination?
Thank you, Tiborgo. So on the solar calculator that we'll be sending you, we have essentially at the moment 3 options. We have a 10-hour day, an 11-hour day, and a 12-hour day. So in terms of BEKA brochures that we are issuing now, we base all our calculations on an 11-hour day, which I think is far closer to the norm of, if you wish, a normal evening in South Africa. So you can, however, by changing the numbers, you can make it whatever you want to make it. It's a spreadsheet, and you can really tailor make it to how you wish to make it. So most certainly, one thing you will note though, and it's important to note that there are 6 different quadrants, and those 6 quadrants have hours in them. And it's important to note, obviously, we have winter and summer. So the 4th quadrant, at least the 5th quadrant, it used to be the 4th, it is now the 5th quadrant. We've extended to 6 quadrants. That will move with the seasons. So meaning that while your 5th quadrant may show 2 hours, it may extend to 2.5 hours in the winter, but it also may come down to 1 hour in the summer. So that quadrant itself, as far as the intelligent charge controller, most certainly will be a movable quadrant to cater for change of seasons. Does that? I hope that answers your question. But you're welcome to contact me at any time to go through the solar calculator with you, or your salesperson, which will also know how to do that.
Okay, thanks, Gordon. Then Boitumelo is asking, what type of after-sales support do you provide, especially for your Lesotho market clientele?
Most certainly, after sales is uppermost in our company's values. And so, Boitumelo, we have a branch, the northern branch, which includes an office which is based in Bloemfontein, that also looks after Lesotho. And most certainly, they have been to Lesotho many times. I think one of the cornerstones of our company is actually to go back to look at projects and to ensure that they're working well and to partner with clients. I think our company doesn't see something as a sale. We rather look at it as a partnership, and we want to walk the full road with you for the warranty period if it's needed and required. Thank you.
Thanks, Gordon. The next question comes from Ntandeni. Is the dimming the best solution because it reduces the battery size? What if I require the whole lumen output?
Okay, and Ntandeni, that's quite an interesting question, and I would love to actually sit with you because this can be quite a long discussion. So I think most certainly there are many ways of skinning the cat. You can reduce your autonomy days. You can push up your autonomy days. So I think it's most important, if you look at the solar calculator, you must just understand, and I mean, you can save the master if you wish and play with the other one. As you move the items highlighted in yellow, as you move those items, you will yourself see sort of what happens to the battery, and always keep your eye on the battery size, and then in terms of the dimming profile, you will also be able to see what happens throughout that. And if you don't like our dimming profiles and you want to change, I'm using example, the first 5 quadrants to one hour and the last quadrant to 6 hours on an 11 dimming, you're welcome to do so as well. So it's really about the more you understand it, it really is an amazing tool that can work for you. And this is why we've created it, for your use and for our salespeople's use as well. I hope that answers your question. Yeah.
And I think just to add to Gordon, this is where it's important to have a good relationship with your sales person, as they can always recommend to you for your specific application. It's always important to look at the application. We've had applications in, for example, mining conditions, where they actually want us to turn the dimming profile completely around and have lower levels at the start and of the night and the beginning of the morning, and rather have the luminaire shining at its brightest during the middle of the night. So we are actually able to tailor make the dimming profile for your requirement. And as I mentioned for the lithium technology, there is always a possibility to offer you a bigger battery if it requires. Just note that that will require some additional lead time, as we will have to get the supplier to prepare that battery specifically for your application. But it's that's what's nice about solar. It's so flexible, and there's a lot of things you can change, like Gordon mentioned.
Yes, and I think most important, what Gert is saying about battery sizes is very important. And while we're talking really road and area lighting here, I can tell you that we are busy with an amazing project in the Western Cape at this stage, where we are going to actually light up a 5-a-side soccer field with lighting, because they only really need, and we've sort of based it on an hour at 50% for the people to warm up, 2 hours game time, and then it will dim down to 30% to basically indicate for the next half hour that you can go home. So guys, solar is endless. We can do, if you have an idea, we can make it work. Have a chat to myself or your local salesperson, and I'm very sure that we would be able to find a solution for you.
Thanks. Gordon, should I put your email address into the chat?
You're most welcome to do so.
Okay, I'll be doing that just now. I'll quickly read the next question from Kaya. Have you experienced any issues with theft of the batteries? Beside the spikes, are there other ways of protecting the batteries from theft?
Perhaps, Gert, you want to comment there?
Yeah, look, the problem of theft of batteries, unfortunately, will be with us for a long time. But I think when it comes into this was kind of the birth child of what you see now is the solar pole, where it is not so obvious as to where to find this specific battery, and because of this fact. And the shape and function of these batteries, we have seen a major reduction in people trying to tamper with something like the solar pole, for example.
And just on that, most certainly what we have found is a lot, and we talk about theft here, Kaya. We see a lot of times municipalities, and you may have noted that municipalities are now saying, oh, the underground cable has been stolen. So what are they doing? They're trying to put bundle conductor up on a standard pole. And not long after the first storm, you would see that all the poles have actually snapped off, and they're lying on the ground because they are not able to take that weight between poles of the bundle conductor. So, and again, please have a chat. Either you're most welcome to contact me directly or your local salesperson, and we have a solution for you. We have a retrofit solution. So if you look at our brochure in the solar pole, you will see that the retrofit option is contained there. We also know that on high mast installations, that Eskom, let alone not having power, but they are battling to even catch up on the connections to high masts. So we have a solution there as well to retrofit the high mast with solar. So guys, the opportunities are endless, and please engage with your local salesperson.
Thanks, Gordon. Okay, are there any more questions? Okay, good. So then we're going to say thank you. Thank you for your time. Thank you for joining us.
I think there's a hand up there. Sorry, Nadia.
Oh,
I think
Dennis.
Yeah.
Yes, thank you. I just want to check with Gordon, because now he just mentioned the issue of now retrofitting the high mast to solar. But now our challenge is our current solar, it's a 30 meter, and now when I look at these calculations, it's working on a 20 meter one. So if we are saying retrofitting, I believe to a certain area, I can say it might be a challenge. Can you just comment on that?
Yes, Dennis, thank you. Nice to hear you on our line. Thank you for that. Dennis is from Polokwane. We know each other quite well. Dennis, yes. So just in a nutshell, if one is going to do a retrofit, remember we've looked at a couple of things because it has to make financial sense, Dennis, if we do that. So you don't want to go and put a whole new mast there. So we've negotiated with the mast manufacturers, so both sectional poles and lighting structures. And you know, obviously, because certain municipalities have certain winches in their stock, so we don't want to cross over that bridge. So what we do, Dennis, is actually reduce the height of that mast, so down to 20 meters, and then we fit the solar onto that. Now, by coming down the 10 meters, you don't have to increase your foundation size. The structure from 20 meters down is also able to carry the additional load, which is now going to be in place, and they've done the load calculations on that. So really all you are paying for is for the mast manufacturer to come out to site, take down the mast, slice back down to 20 meters, fit the retrofit kit on, and obviously we've also say that within the mast there were electrics and all of that. You can remove that because the people break in there and steal it anyhow. So we're saying you can remove all of that. We are also currently working on a solution where we also know that the people actually cut the cables within the mast. So we have a fixed solution which goes on top of the mast as well, Dennis. So we should be early in next year releasing that. That means they can't cut the cables and drop the ring and steal the solar stuff on top as well. So we've most certainly taken, and perhaps it's time that I drive up to Polokwane and come and see you guys, and we have a presentation with Johan, and we sort that out.
Okay, thank you.
Thank you, Dennis.
Great. Okay, then VJ has also got a question.
Good morning. Can you hear me?
Yes, we can, VJ.
Morning. I want to find out something. What I need to know is on your battery autonomy, what is a realistic number of days to use? Because if you look in the last 3 weeks, we barely had a full days of sun.
Perhaps.
Okay, Vijay, yeah. Look, we do a standard calculation in terms of autonomy, like we explained in the calculation for, let's call it 2 days or 3 days. Yes, there will unfortunately be weeks that we cannot cater for, like you say, where you have like 4 or 5 days sort of rainy conditions. But we do, in the background, when I do my calculations, we do take, when it comes to the solar panel charging, and this is where it becomes important when one size your panels according to the system and the batteries that you have, that there is, even in a cloudy condition like today, for example, my solar is currently charging, be it cloudy. So we do take to consideration some charging on those days, but I think the major benefit on our new systems are that the charge controller systems we use now actually allow for a additional percentage of dimming for a condition like this, where you say you have more than 3 days sort of rainy conditions, where the charge controller actually will say, right, just before sunset, it measures the voltage of the battery at that state, and then it will say, for me to allow to have light out through the upcoming night that's now coming up, I need to add an additional, let's call it 5% to my dimming profile. So where you would have 100% output for that specific night, you will only have, for example, 95% for that time period, and then it adjusts also the other ones going through the night, so that by morning you will still have a luminaire giving some light, depending on, of course, how much your battery has been able to recharge for that day. And if the next day the sun shines full and the charge controller sees, right, I'm full, then it's back to absolute normal conditions. And this is something we introduced now to allow you to not have a situation where you say, oh, my light is completely off. We do cater that you do have some light for those additional days now when it comes to cloudy conditions.
Vijay, if I can come in there, most certainly what we've done is very simple, is to say autonomy for us has been calculated by essentially you pull out the charging source, which is the solar panel, and therefore without any charge. And as Gert says, we have the panels that we use are able to, in cases, even put some charge back through a rainy and a cloudy day. The calculation you will see is a straightforward calculation on the solar calculator. You're most welcome to also go through all our brochures, and you will see there, that we have used it as if you had to plug out the solar panel and there's no charge. It is a fact that on day 2, day 3, whenever, you will be getting some charge. So if you have a 2-day autonomy, essentially on day 1, you will have your output, but most certainly on day 2, there will be some charge coming in. We have not made a calculation for that, and we've said that's a positive in your bank that we don't want to interfere with. And so that essentially takes care of that. I don't know if that perhaps answers your question or concern, Vijay.
It does, thank you.
Okay, thanks. Then Ruan is asking PWM or MPPT battery chargers.
Ruan, we definitely use MPPT battery chargers. They do perform much better, especially in raining conditions. We have found that PWM, when it's very overcast and conditions, especially in areas very close to the equator, these charge controllers have not been able to perform to the correct levels. So we have completely moved over to MPPT charge setup.
Thanks, Gert. Then Mtandeni is asking about maintenance. How often should solar be cleaned? Example, the BEKA solar pole.
Mtandeni, yes, thank you for that question. Maintenance is important. It doesn't really matter what you have, whether it's your car, your house, and solar lighting. So I think the most important thing is if you were to stay in an area where there are a lot of dust storms, then just, somehow access the top and clean the panel, essentially, when it comes to rainy season. So remember, how cleaner your panel is, how better your charge will be. So most certainly, one would always say, at least once a year, get up there, give the panels a clean over. If you are in very dusty conditions, do it twice a year. And really, it's really area bound, and obviously whatever sort of maintenance tools you have to your disposal, cherry pickers and the rest, it might be advisable to plan a good maintenance schedule just to clean up the panel. Yes.
Yeah, especially I think for BEKA solar and applications like that. What's nice on the solar pole, for example, is because the panels are in a vertical condition, dust and stuff kind of struggles to really stick to a vertical surface, so they tend to stay cleaner much easier.
Okay, do you have any more questions? I can't see any more.
No, I think that's it.
Okay, so then I'm going to say thank you now. Thank you, everyone. Thank you for joining us. So as discussed and mentioned, we will be emailing to you our solar product brochures. as well as the solar calculator and the presentation during the course of next week. So this will also include a link to the recording of this webinar, but this webinar recording will also be posted on our YouTube channel. So we do encourage you to visit our website or to get in touch with the relevant branch should you require more information, or email Gordon as discussed. So if you don't mind, I'm going to quickly launch a poll. So we would really appreciate your feedback here. It's just 3 very short questions, and you will have approximately 10 seconds to answer each question, and we would really appreciate your feedback there. So thank you so much and have a great day further.
Nadia, you cut off for some reason.
Sorry, I was a bit too eager to mute myself. Sorry, a great day further in case you didn't hear that. I'm trying to find my poll. Sorry, I'm getting there.
I think colleagues, just a heads up. You know, solar is amazing. I think, you know, if you have an idea, share it with your salesperson. Your salesperson will come and have a chat to Gert or myself or the team. And, you know, when the idea came up of lighting up a 5-a-side soccer field, you know, it was an amazing opportunity, and we're getting it right. So please, if you have any ideas on lighting solar has limitations. We all know that, but let us try and see if we can really make the solution work for you. And I think as one of the guys mentioned, you know, we have a hybrid solution which is on the way as well, which would work either from solar charging the stuff, or naturally, you know, a UPS type solution. But also based on that, we have to make sure that we've got permanent power to that pole through the day, so that the charger can actually charge up the battery again. And what somebody has done is actually put the third phase of a 3-phase on charge, so at least every third light is then burning sort of on the battery option. So there are many options, and be creative, be innovative, and share your ideas with us. Thank you.
Okay, thanks. I'm going to launch the poll now.
It's in the chat section, guys.
Thanks, Gordon. Okay, you should have seen now 3 questions.
Yes, that's all come through, Nadia.
Fantastic. All right, thank you. Have a nice Friday and have a good weekend.
Thank you, everybody.
Thank you, everybody. Have a good week. Thank you.
Thank you, guys.
Bye-bye, everyone.